Okay, so here we go. Let's go ahead and move on to section 4.4 on page 239. We're going to talk about congruent triangles. Okay, congruent triangles, triangles that are the same. Okay, so if you go to page 239, in the middle, there's a properties of congruent polygons. Okay, and it has the polygon, especially the triangle on top, and looks like a rectangle on the bottom. Okay, and it says the statement there is triangle ABC is congruent to triangle DEF. Okay, so we have what is called corresponding parts. Okay, corresponding parts. Okay, so if I have A, B, C, and I have R, S, T. If I say the triangle ABC, this triangle here is congruent to triangle RST, okay? So this is what we call the congruent statement here, okay? This is the statement itself, okay? Now, one thing you have to be very careful with here is that you can say triangle ABC is congruent to triangle RST. What you can't say here is that you can't switch the order here, okay? You can't say SRT, SRT, okay? They have to be in exact same order. So ABC, RST, okay? So they are core. So I should be able to, in other words, I should be able to look at the statement itself, and without even having the pictures, I should be able to say that, okay, AB is congruent to RS, BC, the corresponding part to BC is ST, the corresponding part to CA is TR, or I can also say that the angle ACB is congruent to angle RTS. So there's ACB, so this angle, as you can see, is the same as RTS, okay? All right, so so in other words, they have to be matching the corresponding parts, okay? So the corresponding parts to AB would be what? Would be RS, right? AB, RS. AC would be RT, okay? So this guy and this guy are the same, and then this guy and this guy are the same. Same thing with the angles. This angle and this angle is the same. This angle and this angle is the same. This angle and this angle are the same. Okay, so each has to match its corresponding part. Okay, all right. So let's go to example number 1 and see if we can utilize this.
Mr. On.
Yeah, again, like I said, you have to have those triangle nomenclatures, the parts ABC to RST in the same order, okay? Okay, let's do example number 1. Triangle RST and XYZ represent the triangles of a space station support structure. If RST and XYZ are congruent, identify all parts of the corresponding parts. Okay, so actually I should be able to do this again without drawing the picture, right? Because I've been told that this is the corresponding statement. So that means that angle R, the corresponding part to R would be X, would be congruent to angle, angle X, okay, angle S would be congruent to Y, T to Z, right? And then also RS is the same as XY, ST is YZ, RT would be XZ. Okay, all right. So I'm not going to go ahead and write them all out, but you get the point, right? So RS, the first and the second letter, would be XY, the first and the second letter, right? RT, the first and the last letter would be XZ, and then ST would be YZ. Okay? All right. Example number two, we are told to, using the corresponding parts of the congruent given, find, given that triangle EFH and a triangle GFH are congruent. So we have EFGH. Now I'm told that this guy here is 90 degrees. Okay, so this triangle here is congruent to this triangle here. Find the value of X. So I'm told that this guy here is 6X minus 12. Well, if this guy is 90 degrees, that means this guy has to be 90 degrees because angle FHG is the same as FHE. FHE, so this angle here, actually, since they're congruent, it's got to be 90 degrees, right? So in other words, 6x minus 12 is equal to 90 degrees. Okay, I would move the 12 over. 6x is equal to 102. X is going to be, so if I divide both sides by 6, you get x is equal to 102 divided by 6, 17. X equals to 17. Okay, so that's the value of x. And then find G, angle GFH. Angle GFH. Okay, well, what else do I know here? This is 21.6. Okay, so I want to know what angle GFH is the same as angle EFH. So I'm basically looking for this angle right here. And since this is a right triangle, I know that that one was going to be 90 minus 21.6, because this plus this has to be equal to 90 degrees. So I also already know that this guy here is 90 degrees. So this is going to be 68.4. Okay, 68.4. That's correct. Okay, so that's good. Do you have any questions so far? Are we doing okay? Anybody have any questions? Okay, example number 3. Example number 3, it says, proving the triangle is congruent. Given that P and M are right angles, angle P and M are right angles, angle R is the midpoint of PM, and PQ is congruent to MN, and QR is congruent to NR. Prove that PQR and MNH are triangles. So we're going to have looks like this, and I'm going to have PQR MN QR MN PQR MNR. Okay, so we've been told that PQ and MN are congruent. We've been also told that QR and NR are congruent. Okay, we were also told that PR is the midpoint of PM. That means that this guy has to be congruent with this guy. Okay, so we have a situation where the 3 sides are all congruent. Okay, now I've been told that this is 90 degrees and this is 90 degrees. And then I have what? And our angles, okay? So since I know those two are 90 degrees, but I also know that this guy here and this guy here, so in other words, angle QRP and angle NRM are congruent. They're the same. Why are they congruent? Can anybody tell me that? Can anybody tell me why these two are congruent? What angles are these called? Anybody tell me what angles they're called?
They're right angles.
No, they're not right angles. These two are right angles. What are these two right angles over here?
They're vertical angles.
They are vertical angles. Thank you. So these are vertical angles, so they are the same, okay? So if you look at this triangle and this triangle, I have two angles that are the same, which means that the other angle here and here has to be the same, right? We had a theorem that said that. Okay, so we have all the corresponding parts are the same. These angles are the same. These angles are the same. These angles are the same. Look at the sides. This side and this side are the same. This side and this side are the same. This side and this side are the same, which means that all the corresponding parts are congruent. Therefore, we can say that the triangle PQR is congruent to triangle. So let's the corresponding part with P would be M. Corresponding part to Q would be N. Then R is shared. So it goes like that. Again, you have to be very careful to make sure that the order is correct. Okay. I'm not going to go through the two-column proof here. You can read it, but it basically says what I just told you. Okay. All right. And now let's look at example number 4. Okay, example number 4. We have a bars, a structure sport and roller coaster, and they look like a rectangle. We have JK, L, M, and then we have N in the middle. Okay. Okay, given that JK and KL are 90 degrees, so this guy here is 90 degrees. And and ML and KL and KL are also perpendicular. Then we have KLJ, this guy KLJ here, this angle, and LKM, this guy here are the same, they're congruent. We also have JK and ML are the same, JK and ML are the same. And we also have JL and MK, JL and MK are the same, so the diagonals are congruent also, okay? We're trying to prove that the triangle JKL is congruent to the triangle MLK. Okay, so MLK, this triangle here, and JKL, this triangle here, are congruent. Okay, so let's see if we can do that. So we have so JK and ML, are they congruent? JK and ML, they're congruent, right? We were just told that. KL and LK, well, they're the same, right? So So they should be congruent. JL and MK. JL and MK are congruent. We were given that. So that's given. Okay, let's look at the angles. Angle J, so angle JKJL, this guy here. Can I say that this angle here and KML, this guy here are the same? Well, I can because it's a right angle, right? It's a right angle, and I know that this is a right triangle. It's a right triangle. This is 90 degrees, and I know that this guy here and this guy here is also a right triangle, okay? And this guy here is the same, which means that the other angle, this angle and this angle has to be the same. So angle JK, so KJL is the same as LMK. LMK, right? They're the same. We were given that MKL, JLK are the same. We were given that. And we were also given that this guy here is perpendicular, so that's 90 degrees. And this guy here is 90 degrees. So the three angles are also congruent, okay? So the three angles were congruent, the three sides were congruent, therefore, and the corresponding parts were correct. Therefore, we can say that this triangle is congruent to the other triangle, okay? Again, I'm not gonna go through the actual two-column proof. You can read that. Okay, but it should basically say the same thing that I just said. Okay? And that's it. We're done with 4.4. Are there any questions on 4.4?